Bohr's model. In 1913, a Danish scientist, Niels Bohr, proposed a theory for atomic model based on Planck's quantum theory of radiation. The main postulates of Bohr's model are as follows. Electrons are moving with high velocity around the nucleus in specified paths called orbits or shells. As long as the electron is in a particular orbit, its energy is constant. So, these orbits are called stationary orbits or stationary shells and are designated by K, L, M and N. Each stationary orbit corresponds to a definite energy. The orbit close to the nucleus has less energy compared to the orbit away from the nucleus. When an electron jumps from higher energy orbit to a lower energy orbit, the difference in energy is emitted as radiation. The angular momentum of the electron revolving in a stationary orbit is equal to integral multiples of h by 2 pi. Therefore, MER is equal to NH by 2 pi, where N is an integer and named as principal quantum number. M is equal to mass of an electron, V is equal to velocity of electron, R radius of circular orbit, H is equal to Planck's constant. Defects of Bohr's model. Bohr's model could not explain the atomic spectra of higher elements such as helium, lithium, beryllium, which have more than one electron. Splitting of spectral lines in the presence of magnetic field is called Zeeman effect. His model could not account for the Zeeman effect. He could not justify the quantization of angular momentum. Bohr's theory could not account for the formation of chemical bonds.